architecture is a funny blend of graphics and notes. Obviously, whatever you do, you need to do according to the regulations. So when you do a diagram for a builder, you have to do the diagram illustrating what must go where, how it must be dimensioned, and how it must be built. And accompanying that, you need a bit of regulations or notes that say this tread must be this high, this step must be this high, the railing must be so high, the head height must be so high. And it explains the limitations so that the builder, if he gets it wrong, it's evident that the fault is with him. If you just pass your drawing through the municipality, sign it off, and there's no, it's not a good blueprint to build with, there is a chance that it's going to come back and bite you. So the notes are just as important as the actual drawings, diagrams, things like that. Now what normally happens is a person collects notes, and they collect a bunch of notes that they can use and cut and paste and things like that. But the national building regulations are changing all the time, and you have to go back and check, is this right, is that right? You can't just one size fits all. It's not a one button profession. The profession relies on the artistic ability of the architect and his engineering attention to detail to make the actual blueprints for a house that's going to be successful. There's nothing worse than building something and the door hits the toilet or the basin or something like that. You can't get in. So with that in mind, let's have a look at a couple of processes that are involved in the humdrum side of architecture, where a tool has recently been developed to address this. So this is a typical drawing. On the side here you'll notice the notes, and it goes on to next pages, the calculations, the actual drawings themselves. You'll notice that there's dimensions and there's labels and there's little pointers, and this must be so that's a typical drawing. Now how would you have got there? Sometimes you would take some other notes that exist or that you've done before, or that someone else done, or that's involved in the actual building of that one, work around those. You would then go through and make a set of notes that you would then copy and paste onto the drawing. You generally won't use a CAD system to make the notes for your CAD, for your drawings. The CAD system's good, but it's not that good. You would use something that's more versatile, you know. And of course, where would you start off with? You'd start off with the National Building Regulations. Now, anyone who's been through the National Building Regulations will realize that, like in this case, it's Part K, or walls. The building regulations, or the drawing, the final drawing, will need to be submitted with this SANS form that specifies that the designer has taken into consideration all these parts of the building regulations, and this is Part H, Part J, Part K, Part L, Part M, Part N, and you tick it and you say, yes, I've complied with it, yes, I've complied. Well, fantastic. Now, the municipality will look at what you've complied with and say, okay, it's compliant. What if it isn't compliant? What if you missed something? And then later on, they've passed it because you stated that you've complied. And then it's built. Now all of a sudden there's a problem. Now it's costly. So if you're going to state that my drawing is compliant with the National Building Regulations, then you must actually go through each and every section and check each and every part and make sure that it is. So how do you do that? You get from the South African SABS, South African Bureau of Standards, you get all the different regulations for the different parts. This particular one is walls. Remember, you got roofs, you got floors, you got foundations, you got walls, you got balustrades, staircases, a whole whack of different components to the building regulations, not just walls. But this is one document. So now you go through the document, and there they are: general specifications, dimensions, public safety, site operations, excavation, foundations, walls, floors, roofs, stairways, glazing, lighting, method, drainage. These are the sections you need to go through, each document being like this one. So now you get your definitions, just in case you don't know what brick force is. There's a brick force, gives you the definition. If you want the builder to know, you would use this, take the legal jargon and reword it for your actual drawing. Okay, and as you go through the actual regulation itself, you'll find sections that pertain to what you trying to convey to the builder. Sections like, let's just take boundary walls for instance. Very few people realize that boundary walls are regulated. You know, they just think, oh, you just build a boundary wall. But okay, we get in there. They're not. Okay, there's the boundary walls. There's different types of boundary walls. There's the chart, freestanding or solid units, and there's a chart for freestanding hollow units. And from this type of chart, you would concoct your notes. You would say, let's just take it. I want to build a freestanding wall with hollow units, which are 190 blocks. The maximum height above ground is 1.4 meters high, and that's it. And customer says, I don't want 1.4 meter high wall, that's ridiculous. I want 2.4 meters. Oh, let me see. Best I can do. 190 hollow blocks, 2.3 meters, with piers. Sorry, that's a Z shape. With a Z shape, 590 kink by 190, and it is 2.8 meter lengths kink to kink. He doesn't want a Z shape. Okay, so let's carry on down. The best I can do is a diaphragm wall, 90 millimeter, which is not really a hollow block, but in any case, 2.3 meters high, and 390 by 190. In other words, it's a triple brick with two skins outside, and the middle one would reoccur every 1.4 meters. So he said, that's great, he wants that one. Now, you've got to take that specification, that legal jargon, and you've got to turn it into words that the builder can follow. In other words, please build me a wall using 90 blocks, 2.3 meters high. It must be a diaphragm wall, so in total it must be 390 wide, 3 layers of bricks, but the third brick is only every 1.4 meters. So you've taken it, translated it into English. Now you take it, you put it on a drawing. That's great. That's one section of one part of the National Building Regulations. You can see it carries on, the joinings, everything okay. So a proper drawing that's got every single thing detailed will feature a lot of this notation right through the whole drawing. That's going to take a lot of time. So let's have a look. How can we make it quicker?